Okay, today we want to work on simplifying rational expressions. And um, rational expressions can be written generally looking something like this. These are rational expressions, and we're going to multiply them together. Before we get into the structure of this, these are basically just two fractions being multiplied together. I want to look at a method of doing this. Now, back when we first learned how to do this, we kind of, some of our teachers taught us some things. One way would be to multiply 12 times 25 and 35 times 24 with big numbers. Then we learned how to reduce, and we said, well, wait a minute, 12 and 24 can be reduced to be divided by 12. That makes 1 and negative 2, and then 5 and 7, or 5 goes into both of these numbers, so divide by 5 and I get 7, divide by 5 and I get 5. That gives me, now 1 times 5 is 5, and 7 times negative 2 is negative 14. So the answer would be negative 5 over 14. Now, there's another way that we're going to do that lends itself to what we're going to do with the algebraic expressions, because we can't quite do that with something like this. This picture is a little more difficult to do that with. So what we're going to do is I'm going to redo this. 12 can be broken down. I'm going to break it down to prime factors. 12 is 2 times 2 times 3. That's 4 times 3, 12. And 35 is 5 times 7. And then when I look at 25, that's 5 times 5. And negative 24 is negative 2 times 2 times 2 times 3. And now to simplify, what I can do is basically if I have the same number on top and bottom of a fraction, they can cancel. If it's only when it's all multiplied together, and these are all multiplied together because this is basically not mine, it's negative 1 here. So now I'm going to cancel the things that are the same on top and bottom. So a 2 and a 2. This 2 can cancel this 2. This 3 can cancel this 3. This 5 cancels this 5. And there's no more 5s, and that's all. So now the answer would be just multiplying straight across. The only thing left on top is the 5. And the bottom is 7 times negative 2, which is negative 14. So there's my answer, negative 5 over 14. Now, I'm not saying that if we have a fraction like this, we shouldn't do it this way quickly, but this is a method that can be done, and this type of method is how we're going to do the next problem. So when I look at something like this, I'm not sure. What some people start to do is they say, well, I'll just cross off the x squareds. That's not allowed because these are trinomials and binomials. You can't cancel when things are added or subtracted, only when they're multiplied. So this is not a method to do that. So we're going to go back and say, what can we do? Can we factor this? So let's see if we can factor this expression. And I remember my factoring. We have to be good at factoring. So x times x gives me x squared. And now numbers that multiply to get 30 and subtract to get 1. That's going to be 6 and 5. And then the bigger number gets this sign, so that's a minus, and that means that's a plus because it has to be negative 30. That's the top of my fraction. This is a quick difference of two squares, x squared and 6 squared. So it's going to be x plus 6 times x minus 6. And then times this one here can factor the same way, x and x. I'm looking for numbers that multiply to 24 and add to 10. 12 and 2 subtract to 10, that doesn't work. 6 and 4 add to 10, so 6 and 4. This plus means they're the same sign, either plus plus or minus minus. In this case, it's because it's that, it's going to be plus and plus. And then the bottom one factors, I'm looking for this one, and I say, well, this is going to be x and x. I'm looking for numbers that multiply to 16 and add to get 8. 16 is 4 times 4. That works out perfectly. And then I put a plus and a plus. So just factoring is what we have. Now we have things that are factored. So up here we had things added or subtracted. Now we have things that are multiplied. This whole thing is one number. This whole parenthesis thing is another number. This is another number and another number. And what I can do is everything is multiplied now. And then over dividing, now the bottom's all multiplied. So what I can do now, I can start to cancel numbers that are the same. Now basically x minus 6 is the same as x minus 6, so that's going to cancel. X plus 6 is the same as x plus 6. Remember, when we multiply, it just makes it one big fraction multiplying across. And then x plus 4 is the same as x plus 4. And I'm left with an answer that says x plus 5 on top and x plus 4 on the bottom. So basically, that's going to be my solution to this, my simplified expression. So basically what they're saying is every number I put in for x will be the same if I put it in this whole thing as if I put it in here. There are a few exceptions. For instance, 6, x can't be 6 or negative 6, but we'll get into that a little bit later. That's for multiplication. Basically, we factor each expression on top, each part of the fraction, and then I can cancel what I can cancel. Over here, this means divided by. So I'm going to just remember my old rule about dividing fractions is we keep the first fraction the same, so that's going to be x squared plus 14x plus 45 over x squared plus 9x plus 20. And then divided by this fraction means multiplied by the reciprocal. So up here, then it goes 10x third plus 20x squared. And the bottom is x squared plus 11x plus 18. So all I've done is in dividing fractions, we flip the second fraction upside down and multiply. And now this problem looks like the one we just did a minute ago. So we're going to factor the top. X squared plus 14x plus 45 becomes x and x. I'm looking for numbers that multiply to 45 and add to 14. 9 times 5, that works perfectly. And they're both the same sign, they're both pluses. And the bottom of the fraction now, x and x gives me x squared, multiply to 20 and add to 9, that's going to be 4 and 5. They're both the same sign and they're both pluses. This one I look for common factors. That's always what I should do first anyway. Common factors here, that's going to be 10 x squared, parentheses, x plus 2. And then the bottom of the fraction is x and x. And I'm looking for numbers that multiply to 18 and add to 11. 2 times 9, and they're both the same sign, both pluses. And now I have a bunch of stuff multiplied. Now I could have changed this 10 to 2 times 5. That's not going to make a difference in this case. If I did have a 2 down below, I could do that, but that's just fine as it is. So I look at this and say, do I have any common factors on top and bottom that I can cancel? And when I say common factors, I'm not looking for just the 9 or the 2 or the 5x. I'm looking for this whole thing as one factor. And there's an x plus 9 here. Let's go with that. There's an x plus 9 here and an x plus 9 here, so those cancel out. There's an x plus 5 here and here. They cancel out. There's an x plus 2 here and here. They cancel out. And nothing else can cancel. So this x doesn't cancel with this x because of the x plus 4. So the answer then would be 10x squared over x plus 4. So these kind of problems just take a lot of practice. So hopefully in working on your homework tonight, you shouldn't have too much trouble with this. Okay.